Alright, here's some notes on how to get something into vertex form, because yesterday we just worked on graphing things that looked like this. And it was really easy because A was the vertical stretch or shrink, or it could make it flip upside down. This was the shift up or down, and this was the shift left and right. So when something's written in this form, which is called vertex form, because you can tell where the vertex is, then it's really easy to graph. So if you look at these here, to turn something that looks like this, standard form, into vertex form, you can actually do it pretty easily. And it's kind of nice because you can find the vertex, h comma k, with this handy little formula. The first thing you do is you take that b, opposite of b, over 2a, that a, and that's your x part of the point, right? That goes right here in the x part. Now what goes in the y part is f of h. So that means you plug in your answer for this, so that negative b over 2a. You're going to plug in your answer to the original equation for x, and that will go be your y part. And after you know the x and the y part, you can write the equation. So here's a quick example where everything's kind of done for you. A is 3, b is negative 12, c doesn't matter. Okay, so if I asked you to find the vertex, you would start with negative b over 2a. So I would say, okay, a is 3, b is negative 12. So negative b would be 12 over 2 times a, which is 6, and that equals 2. So what that tells me is my vertex, the x part is 2, and I already know it. How do I find the y part? I plug a 2 into the original equation everywhere you see an x. So I'm going to plug a 2 in there and a 2 in there. So if you see this, that's why it's 3 times 2 squared minus 12 times 2 plus 7. You type that in, and you get negative 5. So that tells me my vertex is 2, negative 5, which is why you already know this part of your equation and this part of your equation. So the last question is, what is the a? Well, good news, folks. The a is the a. The a from quadratic formula is the same a that's in front of here. So if there's a 3 in front, there's still a 3 in front. And it's x minus 2 squared minus 5. So let's try one of these, and you'll see. Here's an equation that is not in vertex form. This would not be easy for me to graph. But if I take a minute and I say a is 1, b is 6, and I go negative b over 2a is like taking a negative 6 over 2 times 1, also known as negative 3. What that tells me is my vertex has an x part of negative 3. What's the y part, you may ask? Well, all I have to do is take that negative 3 and plug it in there and there, and I will know. So f of negative 3 means take negative 3 squared plus 6 times negative 3 plus 11. Now put that in parentheses or you're going to get it wrong, because negative 3 squared is 9 plus, and that's negative 18 plus 11. So if I do 9 minus 18, I'm at negative 9, and negative 9 plus 11 is 2. So I know the vertex is at 3, 2. So my equation, I already know the a is 1, right? So I don't need to write a number in front of it. It's going to be x plus 3 squared plus 2. Isn't that nice? There's my vertex, x part, y part, and there's a 1 here. You can write it there if you feel like it. Just don't forget the squared, because, reasons. Alright, so next one, same deal. A is 5, b is 40. So I'm going to do negative b over 2a, which is negative 40 over 2 times 5. And my answer is negative 4, which means the vertex is at negative 4 comma something. And remember, I find this something by taking this guy and plugging him back into the original equation, 4x. So I'm going to go and say, okay, g of negative 4 is 5 times negative 4 squared plus 40 times negative 4 minus 3. And that's 5 times 16 plus 40 times negative 4 minus 3, which if I do 5 times 16, that's going to be 80, plus 40 times negative 4, oops, which is negative 160, minus 3 is going to be negative 83. So I know my y part is negative 83, which means my equation is going to be y equals, now the a comes from that a, right? I'm going to have a 5 in front, x plus 4, remember the x is always lying to you, and minus 83. Crazy equation, right? All right, last thing, here we're going to write the function in vertex form, identify the vertex, axis of symmetry, y-intercept, tell which way the graph opens. Seems like a lot, but it's not really. So once again, negative 2, b is 16. Negative b over 2a would be to take negative 16 over 2 times negative 2. So negative 16 over negative 4 is 4. So I already know part of my vertex is 4. The other part, once again, I get by plugging in the 4 to the original equation. So h of 4 is negative 2 times 4 squared plus 16 times 4 minus 34. So we got negative 2 times 16 plus 16 times 4 minus 34. And then that's negative 32 plus 16 times 4 is 64 minus 34. So here we're going to have 32 minus 34, and that is going to be negative 2. So I know my y part is negative 2, and then I know my equation is going to be, remember you grab the a from here, that a is negative 2 times x minus 4 squared minus 2. So the x part lies to you, the y part tells you the truth. So there's my vertex. There's my equation vertex form. My axis of symmetry, remember I steal the x part of the vertex. Kind of like yesterday. And lastly, the y-intercept. I don't know if you remember this, but we've done this earlier in the year. The y-intercept, you plug in 0 for x. So the original equation, I'm going to put a 0 in everywhere for x. Negative 2 times 0 squared plus 16 times 0 minus 34. And those go away, and you're just left with negative 34 as your y-intercept. Or you could write the point 0, negative 34. And I think that's, oh, which way is it open? Opens down. You know how I knew that? Because a is negative. So since the a had a negative 2 in front, or here, remember flips upside down, I know it opens down. So that's your stuff for today. You should be able to crank through the work. Good luck to you. Talk to you later.